Okay. Uh, I think already you have seen this graph in the I had sent one PDF file of standard Proctor test, and with this graph also you have seen in that PDF file which I had sent to you. So already we have discussed what is the compaction, what is the relation between dry density and water content. Okay, so now the this graph normally represents the relation between the maximum water content or maximum optimum moisture content to maximum dry density value. So from this graph we can get the idea at which optimum moisture content the soil will give us the maximum dry density. Okay, that things are clear or already I have discussed in the last class. So this curve pattern or this kind of curve or graph is useful, or this is our we can get from the values when we have the data of water content as well as corresponding dry density value, and after plotting in the simple centimeter graph paper we can get the optimum moisture content or the optimum water content and maximum dry density. Simply the name of this plot is optimum moisture content versus maximum dry density graph. Okay, this is the main compaction characteristics through which we can identify at which water content soil will give us the maximum dry density. Now another thing you can see in this graph, that is the zero air voids line. Along this your water content dry density or water content dry density plot, you can see another line is there. The name is written here, the zero air voids line. Okay, what is zero air voids line? Normally, as per definition, a line which shows the water content dry density relation for the compacted soil containing a constant percentage air voids is known as air voids line. So, acha, and can be established from the relation. So, a line which shows the water content dry density relation for the compacted soil containing a constant percentage air voids. Okay, constant percentage of air voids. Percentage of air voids, already we had the equation in our first chapter in soil mechanics, in soil mechanics 1, percentage air voids. What is percentage of air voids? Volume of air. It is a relation between volume of air to the total volume in percent. Okay, that is percentage of air voids. VA by V, capital V A suffix by V, volume of air to the volume of total soil into 100, that is in percentage. So these lines actually the value of percentage of air voids. So you are adding some water with soil and you are getting some density as well as the dry density. At the same time, what is your percentage of air voids at that time after adding the water? Suppose you are adding 9% water, say 9% water, add 9% water, and you are compacting your soil and you are getting some density value as well as the dry density value corresponding to water content. Same, when you are adding 10% water with your soil, you are getting some density. After compaction, you are getting some density as well as the dry density. Same as at that stage, when you are adding 9%, 10% or 11%, whatever your percentage of water content, and after adding the water content with the soil, you are compacting your soil as per procedure, and you are getting some density, or simply you can say bulk density, and water content and bulk density is available, you can getting some dry density. But also at that stage, what is your percentage of air voids in the soil, you should calculate. But this is another test, and when we are performing this compaction characteristics test, suppose the standard Proctor test, the basic test, or compaction under compaction characteristics, first test is the standard Proctor test, and it will come under the light compaction test. There are two tests normally: light compaction test, heavy compaction test. Under light compaction test, standard Proctor test is the important, and it will come first. And normally we are performed in our laboratory in general cases for all the experiments. Before performing any experiment in the laboratory, first we perform the light compaction test, that is standard Proctor test, to find out the maximum dry density and optimum moisture content of the particular soil. So when we are perform such type of test, or such or this standard Proctor test or light compaction test, along this test we can also find out the zero air voids line. Okay, so zero air voids line, another parameter in the same test we can calculate. Normally whatever I have said in the last class, this is actually our objective, but along this objective we can also find out the zero air voids line, which can give us the some idea, which idea, which will give us the some idea regarding the what is my percentage of air voids in the soil at that time when we are when I am adding, suppose 9% water content, 10% water content, 11% water content, and I am compacting my soil. Already you know the some mold is there, and we normally we are compacted that mold, and we are find out the density of the soil, bulk density as well as the dry density. At that stage also we can calculate the percentage of air voids, and when the this water content value and this dry density value is available, also this zero air voids line can be also can be zero air voids value can be calculated, and when these zero air voids values are available, we can draw the zero air voids line. But the significance of this zero air voids line is to show the percentage of air voids, the amount of percentage of air voids in the soil, okay, corresponding to water content and the dry density. There is one formula, just wait, I am showing you. So this is the formula, okay, to find out the zero air voice line. Normally rho d is the dry density, as we know the rho d is the dry density, and formula is 1 minus Na. Na is the percent air voids or percentage air voids. G specific gravity, rho w unit weight density of water by 1 plus Wg. Water content, small w is the water content, G is the capital G is the specific gravity. So this is the formula through which we can find out the value of air percentage of air voids from this formula, as well as the all the values which are required for the zero air voids line. Same has written here, the N is the percent air void, water content of compacted soil, rho is the dry density corresponding to W, G is the specific gravity, rho W is the density of water. The theoretical maximum compaction for any given water content corresponds to zero air voids condition. So theoretical maximum compaction for any given, so when your soil is maximum compacted at that stage, suppose at some water content corresponding to zero air void condition, your Na should be 0, percentage of air void should be 0 when your soil is maximum compacted at any given water content. At that stage, the percentage of air void would be 0. The line showing the dry density as a function of water content for soil containing no air void is called zero air voids line or the saturation line. So these are the different description in different perspective view. So the line showing the dry density as a function of water content of for soil containing no air voids. Okay, when your soil is maximum compacted, at that stage the voids would be 0. When the water content is maximum, your soil will give you the maximum 0 less percentage of air voids. So percentage of air voids depends on compaction or the maximum density as well as the water content. So when the density is maximum, density of the soil is maximum, the percentage of air voids would be less. When water content is maximum, percentage of air voids would be less. So two factors are there. One is density, another is water content. If you increase your density of your soil, the percentage of air voids will be less. If you increase the water content in the soil, the percentage of air voids would be less. So this is the common things which will normally happen in soil mass. And as also we know, these maximum dry density only can be achieved by adding some percentage of water. Okay, without water we cannot achieve the maximum dry density. So some percentage of water should be there in the soil, then only we can get the maximum dry density. And normally we are perform this test to find out that much of water content. So what is that water content where soil will give the maximum density? Okay, so normally if we draw the zero air voids line, it will show like that. Okay, it will show like that, it will show like that. But how can we draw this dry density versus water content curve? How can we draw this zero air voids line, or how can we find out this zero air voids values, as well as how can we draw this zero air voids line? I will show you. Where we will perform the compaction test, standard Proctor test. There, these things will be very clear, and we can also able to perform draw these curves. Also, some formulas are available, like rho d also can be expressed by G rho W by 1 plus Wg. Alternatively, a line showing the relation between water content and dry density for a constant degree of saturation S is established from the equation. Degree of saturation also one of the factor which is related to this water content density relation. So as we know, when the water is maximum, degree of saturation is maximum. When soil is completely dry, degree of saturation is less. So this degree of saturation also related to our the percentage of water in the soil. Okay, so percentage degree of saturation, percentage of air voids, these things again are coming. These things are coming for compaction characteristics. But the important thing is to find out these value, these maximum dry density value, uh, at which water content your soil will give the maximum dry density. This is important to us as an engineer. Zero voids line also important to show the air voids value, percentage of air voids value. After that, wait. After that, we have another test, that is modified Proctor test. Okay, modified Proctor test. Uh, just listen. Higher compaction is needed for heavier transport and military aircraft. Military aircraft means for airport, construction of airport. We civil engineers normally involved in every area for constructing airport, for constructing railway station, rail line, to laying the rails on the ground, to making the transport system. For heavy construction we use this test. Yeah, क्या? For heavy construction we use this test, sir. Yes, for heavy construction, this modified Proctor test is used. So the modified Proctor test was developed to give a higher standard of compaction, and this test was standardized by the American Association of State Highway Officials, is known as the modified ASHO. Actually, the name of the American Associate of State Highway Officials, ASHO, AASHO, ASHO. Just what I am writing here, ASHO. AASHO. This is one of the standard normally invented by or the developed by the America. Okay, this is also one of the international standard. Normally we are followed Indian standard, IS code, Bureau of Indian Standard, BIS. Same thing in America, and as well as the this is the universal code. Okay, this is the universal code which is used in America as well as some countries. This is the American code. Name is American Association of State Highway Official. Okay, American Association of State Highway Officials. This is the important one of the important code which we will use in soil mechanics as well as in transportation engineering. Okay. Okay. This ASO. In this test, the soil is compacted in the standard Proctor mold, but in 5 layers. Okay, in the last test, standard Proctor test or light standard Proctor test, light compaction test or light standard Proctor test, we had the 3 layers to fill the complete mold. But in this case, this modified Proctor test, when heavy compaction is needed, at that time we will fill this mold, which mold is normally used, in 5 layers. Each layer being given 25 blows of 4.5 kg rammer. In the light compaction test or standard Proctor test, we had the weight of the hammer is 2.5 to 2.7 kg or sometimes 2.6 kg. But in modified Proctor test, normally we are used the rammer of weight having 4.5 kg. Okay, I will send the PDF, no problem, you will get the PDF. The compactive energy given to the soil in this test is 27,260 kg centimeter per 1000 centimeter cube or 2,674 kilojoule per meter cube. So in our mold size is normally 1000 centimeter cube. Okay, the size of the mold for compaction test is 1000 centimeter cube, and in standard Proctor test we had this compacting energy 6065 kg per 1000 centimeter cube or 595 kilojoule per meter cube. But in modified Proctor test, where heavy compaction is required, at that case the compacting energy given to the soil is 27,260 kg centimeter per 1000 centimeter cube or 2,674 kilojoule per meter cube, almost 5 times. 5 times extra energy should be given to prepare the sample or to measure the density of the soil. Mold size is same equipment is used, just changing in hammer. Hammer is changed in modified Proctor test. Okay, from the standard Proctor test. And other things are same. Also in this graph you can see this is our curve for standard Proctor test. This same curve is plotted here. Okay, this curve for standard Proctor test. At same suppose at 11 11 percentage of water content, it is giving some density value. At 12 giving some density value, 13 giving some density value, for at 14 percentage of water content, it is giving some density value. But at the same time, in modified Proctor test, you can see the at same water content it is giving high density. It is giving you high density value, high dry density. So this is the difference between standard Proctor test and modified Proctor test. But modified Proctor test is completely restricted to for heavier transport and military aircraft. Like also in for airport soil for runway, constructing runway at that stage, for constructing any uh, railway station or transporting heavier vehicle, at that time we need this modified Proctor test curve, otherwise it is not needed to us. In simple cases normally we are followed this kind of tests, this kind of test or standard Proctor test or light compaction test. But when heavier transport required to construct in for heavier transport or to construct the transport system for military service, we are normally followed this modified Proctor test curve. Just difference is in rammer as well as the making this mold, sorry, making this the sample in the mold size is same. Three layer normally used, three layers are used in standard Proctor test. In modified Proctor test 5 layers are used. Compacting energy is different. Rammer, weight of the rammer is different. Okay, I think this is clear. Now we have the methods. Now we have to read out the field compaction methods. Field compaction methods. Already I think you have seen some video in earlier class. Suppose wait, not this video I think. Already you have seen. Acha, normally various types of soils can be compacted in the field by three methods. Okay, rolling, ramming, ramming by impact and vibration. So one is rolling. Rolling one is the method in the field or compaction. Rolling. Okay, roller. Normally roller is used. Rolling, ramming. Ramming is impact, giving impact on the soil. Ramming and vibration. Okay, so rolling, ramming by impact and vibration. Corresponding to this, the various compacting equipments can be grouped under three categories. Equipment method is rolling, ramming, vibration, and equipments. Corresponding to equipments, we can categorize like rollers, rammers, and vibrators. Okay, because rolling, ramming, and vibration is there, so that's why we are categorized as per this method the roller, rammer, and vibrator. For compacting, these are the type of equipments which are used for compaction. The rolling equipments are of 5 types. I'll give all the PDF, don't worry. So the rolling equipments are 5 types. Smooth wheel rollers, already you have seen. Again I'm showing you. The smooth first is smooth wheel rollers. Second, pneumatic tired rollers. Okay. Third, sheep foot rollers. 4. Lorries and pneumatic tired contraction plant. And 5. Track laying vehicles. Track laying vehicles. So there are 5 types of rollers. 1. Smooth wheel rollers. Smooth wheel rollers, pneumatic tired rollers, sheep foot roller, lorries and pneumatic tired contraction plant, and finally track laying vehicles. Track laying vehicles. So I have some examples or some videos you can observe. You can see these are compacting equipments. Hmm. So I have said rolling, compacting means rolling, vibration, kneading is there, but okay. Kneading is in details. We when in details we need to study for modification of soil. At that time, kneading is also there, but mainly rolling, under compacting methods, rolling, vibration, ramming. Okay. Types of roller: smooth wheel roller, sheep foot roller, pneumatic tire rollers. Acha. Sometimes vibratory rollers are there. Shape propelled rollers. There are lots of rollers actually. The main things are smooth wheel rollers, pneumatic tire rollers, sheep foot rollers, lorries or pneumatic tire construction plant, track laying vehicles. Okay, and beside these types of, we have manually propelled rollers, self propelled rollers. This is smooth wheeled roller. Okay, this is smooth wheeled roller, normally used to construct our roadway, our highway. Normally, this type of roller is used. Already, you have seen this video. This is the smooth wheel roller. These roller can be used, okay, by for compaction, but you have to spray some water before rolling on the soil. Without water, if you roll, then it is not useful to us, because only giving some water to the soil or adding some water to the soil, or then the required density can be achieved. Okay, without adding water, the required density cannot be achieved. So it is showing this that only rolling is going on, but before rolling, some sprinkling of water, some spreading of water is necessary. Some advantage, disadvantages are there. We'll talk later, but now the important is type. Important is the type. Next, next. Ah, this is another type, smooth wheel roller. these things actually mechanical things, and daily they are developing new kind of things. So there are various types of rollers. Smooth wheel, basic type is smooth wheel roller, but different companies are there. Cat, uh, lots of companies are there. Then for construction companies, they are constructing. They are constructing daily. They are developing this machine. So this is the mechanical things normally. As civil engineer, we should know the basic types. Smooth wheel roller. भाई मुझे एक smooth wheel roller चाहिए. When we are going to buy roller or as requirement for our construction, we should ask the whatever the companies, whatever the sites. So we should ask the type of roller. Okay, requirements of the roller. This is sheep foot rollers. This is the sheep foot rollers.
सर इससे क्या होता है?
Just now, just see the types. Okay, the advantage, disadvantage I will discuss. I will discuss. This is the sheep foot roller. Pneumatic tire rollers. This is actually pneumatic tire rollers.
सर इसमें रबड़ भी रहता है क्या सर इसमें?
Sometimes. Rubber normally used to make the tire. So rubber should be there. This is the vibrated rollers. This is rammer. Okay. So this is the complete and last is vibrator. I have no example at present. I have no example of the vibrator, but the ramming equipment consists of normally three types: dropping weight type, internal combustion type, pneumatic type. Okay, the most important thing is type of roller. Roller is important to us. Normally same thing day by
सर वॉइस नहीं आ रहा सर क्लियर सही से.
huh yes Please repeat.
सर वॉइस क्लियर नहीं आ रहा है.
Oh, I'm saying that the roller, okay, roller is important to us mainly, and the types of roller, basic types of rollers. Just I have said that smooth wheel rollers, pneumatic tire rollers, sheep foot rollers, lorries, and pneumatic tire construction plant, track laying vehicles. These are the main types of rollers. Okay, I will give you the PDF. But day by day, every day, the implementations are going on. So it is not possible to identify the types of rollers like vehicle. There is, suppose I am going to, suppose I am going to buying a car. What are the basic types? Suppose there is sedan car, hatchback car, okay, like SUV car. These are the main type of car. Normally we know. So I can say the give me the sedan car. I can say give me the hatchback car. I can say give me the SUV car. This is a simple kind of difference. But there is the lots of companies. Here Honda, your Indian normally available mid range companies like your Maruti, okay, Toyota. But there are lots of characteristics, lots of things like VXI, VLXI, okay, ZXI. This is the lots of things. AC, non-AC. Okay, this I think you are getting now. You are getting what I am to say. I want to say. So basic types is important to us. Suppose the types of compaction, the types of equipment for compaction, and types of roller, basic types of rollers. Rammer is there, vibrator is there. Okay, in the rolling section, smooth wheel roller is important, pneumatic tire rollers important, sheep foot rollers important. So these are the basic types. Now if we talk about the advantage, I will give you this video. You can read out from this video the advantages and disadvantages of this smooth wheel roller, this pneumatic tire roller, or this rammer. What are the advantages of these rollers? So I think the under field compaction method, this is the things which is neat for you. Okay, I will finish today. Okay, I will stop here. So just wait. I will take the attendance. Okay, attendance is completed. Thank you. You can leave. Mhm.
थैंक यू सर.
Mhm. Mhm.